To find the value of the limit, we first need to think about what is happening to our function as x is approaching infinity. So we'll have the natural log of a number that's approaching infinity divided by 3 times the square root of a number that's approaching infinity. That's going to give us infinity over infinity, which is one of the indeterminate forms that tells us we can use L'Hopital's rule. So L'Hopital's rule says that there's an equivalent limit that we can find by taking the derivative of our numerator and placing it over the derivative of our denominator. So in this case, if we take those two derivatives, we're going to end up with the limit as x approaches infinity of 1 over x in our numerator and 3 over 2 times the square root of x in our denominator. And we can simplify this. Dividing is the same as multiplying by the reciprocal. So we make this 1 over x times 2 times the square root of x over 3. And we can make that into 2 root x over 3x. And so we can cancel out a square root of x by remembering that x can be factored into 2 root x's. This will allow us to cancel out a square root of x in the numerator and the denominator, and will leave us with a much simplified form, which will be 2 over 3 times the square root of x. Now if we think about what's happening to this function as x approaches infinity, we have 2, a constant, over 3 times the square root of a number that's getting larger and larger in the positive direction. This is going to be the same thing as 2 over that number that's getting larger, which is going to make the fraction get smaller and give us our final answer, which is that our limit is equal to 0.